The distance s meters from a fixed point O covered by a particle after t seconds is given by the equation s is equal to t cubed minus 6t squared plus 9t plus 5. Question A. Calculate the gradient to the curve at t is equal to 0.5 seconds. The curve is given as s is equal to t cubed minus 6t squared plus 9t plus 5. Gradient equals differentiation. So to get gradient, we get ds dt, and ds dt is equal to, when we differentiate, we have 3 times 1 is equal to 3t. 3 minus 1, 2, minus 2 times 6 is 12t. 2 minus 1 is 1, plus 9t is raised to power 1. 1 times 9 is 9. T is now raised to power 1 minus 1, which is 0. T raised to power 0 is 1, and 9 times 1 is 9. 5 does not have a positive power because x here is raised to power 0, which will convert everything to 0. So ds dt is equal to 3t squared minus 12t plus 9. We are told to calculate the gradient to the curve at t is equal to 0.5. So we say gradient is equal to 3t squared, but t is equal to 0.5. So it is 0.5 squared minus 12 times 0.5 plus 9. This gradient at t is equal to 0.5 is equal to, when we simplify, we get the gradient to be equal to 3.75. Question B. Determine the values of s at the maximum and minimum turning points of the curve. At maximum or minimum turning points, gradient is equal to 0. So we are going to say that ds dt is equal to 0 at maximum or minimum. Therefore, our ds dt, which was 3t squared minus 12t plus 9, we equate it to 0 at maximum or minimum point. Because it is a quadratic equation, we can say that t is equal to minus b plus or minus root of b squared minus 4ac over 2a. That is a quadratic formula. Using the quadratic formula, we can say that t is equal to minus b. B is minus 12. So minus 12 will give us positive 12 plus or minus root of b squared is 144. Negative 12 squared is 144 minus 4 times a, which is 3, times c, which is 9, over 2a, and a is 3, so 2 times 3, which is equal to 6. We're going to have t is equal to 12 plus or minus root of 144 minus 12 times 9 is equal to 144 minus 72.